The Midwest is known for its farms. Some raise crops like corn and beans, some raise livestock like cows and pigs, and some do both.
But there's a newer type of farm that's growing in popularity across the Midwest.
It's a wind farm. We hope you aren't afraid of heights. We're taking you to the top of a wind turbine and show you how harnessing the wind will play a big part in our energy future.
We'll also check out a student-built home and see how tomorrow's contractors are learning how to build with energy efficiency in mind.
There are things in your house wasting your energy even when they aren't on. We'll show you how to kick these energy thieves to the corner with new advances in power strips.
And we'll show you how to make sure your new air conditioner delivers the performance you paid for. I'm sure you've seen more of these wind turbines popping up across the Midwest. This part of the country's high flat land is perfect to capture wind to create energy. But wind power is nothing new. It's been around for thousands of years, dating back as far as 5000 BC. The Egyptians are the first known people in recorded history to use wind power. They created sails to help propel their boats down the Nile River. The Persians were using wind energy to grind grain and pump water between 500 and 900 BC. Skip ahead to 1888, when Charles F. Brush invented the first electricity-generating wind turbine in his backyard. It was 50 feet tall, had 144 blades made of wood, and generated about 1,200 watts of power. The turbine was connected to batteries in Brush's basement so he could power his mansion. Today's wind turbines produce a lot more energy than Brush's. You might be surprised to find out how much energy just one wind turbine can generate. We traveled to the Whispering Willow Wind Farm to talk to Tony Vaughn and his team to find out more.
Here at Whispering Willow, we have V82, Vestas V82 wind turbines. Basically, they're 265 feet to the center of the hub. When the blades are pointing straight up in the air, they're about almost 400 feet tall. So at full production, they're spinning approximately 14 RPMs, and the tip of the blade's traveling about 138 miles an hour. Wind farms work to get energy out onto the grid by producing power up tower in a generator. That power is transferred down to a pad mount transformer outside of the turbine, which then sends that power to a substation, basically. Once at a substation, it's put out onto the grid, all the transmission lines that everyone sees out there. From there, it goes back into substations, which can go into some smaller cables out to your homes and businesses. We need about an 8-mile-an-hour wind for them to begin to generate energy. And then on the other hand, there can be too much wind energy as well. So once the wind reaches about 45 miles an hour, the turbines will actually pitch out of the wind, which is the blades will rotate out of the wind so that they're not catching any wind anymore, and shut the turbine down to protect itself. These turbines put out 1.65 megawatts of power, which if you equate that to the power in a home, one turbine at full production can power about 415 homes. Wind energy is important because we want to provide a low cost, low emission energy source to our customers. In doing that, we're reducing environmental issues, reducing our carbon footprint.
Even though wind turbines have been dotting the landscape for the past decade, the technology is still in its early stages, and there are a lot of advancements on the horizon.
I see the future of wind continuing on the same path that it has been the last 10 years. There's new advancements in technology on a yearly basis, which gives turbines the ability to produce power at lower wind speeds. That, working in conjunction with some of our newer gas plants, we're able to see the wind coming across the state, ramp up a gas plant when the wind is dying off, and then in turn ramp that gas plant back down when the wind is there to produce that power. In doing that, that's the best thing for our customers. We're trying to give them the lowest cost energy available.
To see a 360-degree virtual tour of the Whispering Willow Wind Farm, check out our YouTube channel at AE PowerHouse TV.
Besides creating the first electricity-generating wind turbine, in 1879, Charles Brush also created the first electric streetlight with arc lighting. The lamps burned as bright as 4,000 candles. Brush Electric Company was bought by a company that eventually formed General Electric. New homes seem to be under construction everywhere these days, but this isn't your typical home build. This home is being built by high school students. Let's go inside and meet the team. Meet Dave Smith. He's been teaching future generations of home builders for 22 years. And Dave, tell us about this class. I'm fascinated.
It's something I really enjoy doing. I have a passion for it. This year we have 24 students in the class. It's a year-long class, primarily for seniors, but we have a few juniors. They start in the fall, right from the foundation, frame all the way up to the top of the roof, come back in, drywall, insulation, everything.
I love it. We're inside the house here in the family room, and I know energy efficiency certainly plays into the instruction and the teaching with this class.
The advisory team really looks at that. We want it to be a comfortable house for the future homeowner. We want it to be tight, sealed, warm in the winter, cool in the summer. Wouldn't we all want that house?
You bet, you bet. And this house will go on the market, right?
Absolutely. In fact, it's on the market now and will be sold, I'm sure, quickly.
All right. Can you show us around a little bit? And let's talk about the energy efficiencies that are built into this house.
I'd like to take you down the basement and show you some things.
Okay. Dave, I imagine in your 22 years of teaching these students, you've seen a lot of changes in construction.
Oh, absolutely. Well, right above us is manufactured I-joist. And so they're actually created in a factory, and they're straight, they're strong. Kids can put them up really quickly and easily, make a solid house.
And I imagine the focus on the envelope of the house too, that's changed over the years?
When I started doing this 22 years ago, you slapped a little insulation and you called it good. We figured out that it's important to enclose the environment. Let me show you over here. If I take out this fiberglass insulation, you're gonna see back in here this blue stuff, which is actually a spray-in caulk. We spray it with a high-pressure paint sprayer. It embeds itself in the joint, keeping any air from moving. We isolate the air in this bay, keeps it from moving to the other bay. Once it's still, it retains the heat, cool, whatever. We also do all the joints everywhere.
And then how about down here in the foundation?
Down here, it's a little different, simply because behind this styrofoam is a concrete wall. Concrete's right against the dirt. The cold comes in through the concrete. This styrofoam, very dense, stops the cold. It goes all the way down to the bottom of the footer, below the floor, stops the conduction of heat or cool from the outside coming into the floor, keeping the occupant of the house more comfortable. Most basements have a nice cold floor. This one will be whatever the temperature of the earth is, but not colder than that.
Not only is Dave teaching these students how to build a home, he's teaching them how to do it with energy efficiency in mind. When building an efficient home, one of the most important factors is making sure the home has a tight envelope or shell. The envelope is what protects everything inside the home. This includes the roof, walls, foundation, windows, and doors. The tricky spots are where the roof meets the walls, the floors meet the foundation or door, and window frames. These are areas where heat can escape in the winter or vice versa in the summer. Donna, let's talk a little about your class here. What do you really enjoy about this that's building a house?
Well, what I enjoy about this class is you actually start, from cement, and you get to see something actually productive happening and the house get built up, so.
How about energy efficiency? On PowerHouse, we're always talking about energy efficiency. Things that you've seen, the class that you've applied here in this house?
A lot of insulation, going through that and making sure everything's up to code and everything. And we got insulation done probably right before winter, so you really noticed when, you come in one day, the house is cold and you have to turn the heaters on, but then once we got the insulation in, you only had to run them about half the time to work, so.
Well, that's a great thing. So you know that this house is well insulated for whomever's buying it, right?
Yeah.
In an average home, 20 to 40% of air leaks happen around the envelope. That's a significant amount and shows just how important it is to have a tight home. John, what part of the building process have you enjoyed the most?
I enjoyed framing. That was pretty fun.
What about the framing aspect did you enjoy?
Well, I like to use the hammer and hit it all together.
Okay, all right. It's got to be a neat feeling now as you come down the street and you see the house and it's really come together. How do you feel about that?
I feel good because I actually did something in high school I can see like 10 years later.
You bet. A properly sealed home can save you more than $200 a year in heating and cooling costs, or up to 10% on your annual energy bill. Your heating and cooling system will run more efficiently and your home will be more comfortable overall. Gary, this is pretty neat. It's got to be fun for you to be part of a class that's building a house, and it's helping you prepare for a career to get into.
Yeah.
And you're thinking about what?
I'm thinking about welding. I like putting stuff together and then just creating something new.
Dayton, what have you enjoyed the most about being a part of this class, building a house?
Just framing up the walls, putting the walls up. I love doing this stuff. I grew up with my dad doing construction, and I've always wanted to be a part of construction.
Anything that surprised you as you got into this class?
Mudding.
Mudding? Why?
It's just really difficult to get it on evenly and right.
Okay. It's got to be a great feeling as you come down the street and see the house that you've been building?
Oh yeah, I took my mom by it the other day, and she thought it was pretty neat.
Pretty cool. Dave, this has been fascinating. Thanks for sharing this with us today.
Well, I'm really happy you're able to come today, Pete, and learn about some of the things that we're doing with the young people of Cedar Rapids.
Well, it's great for you to share this and again, teaching about energy efficiency and comfort for years to come. And if you'd like more energy-saving ideas, visit our website at PowerHouseTV.com.
How much electricity does a typical American home use per month? Is it A, about 900 kilowatt hours, B, about 9,000 kilowatt hours, C, about 90,000 kilowatt hours, or D, 1.21 gigawatt hours? The answer when we come back. How much electricity does a typical American home use per month? Is it A, about 900 kilowatt hours, B, about 9,000 kilowatt hours, C, about 90,000 kilowatt hours, or D, 1.21 gigawatt hours? According to the Energy Information Administration, the typical American home uses 909 kilowatt hours per month. A dripping faucet can be a nuisance. If it drips once every 5 or 6 seconds, you'll be losing a little over a gallon of water every day. And that adds up over the year. Now the same is true for electricity, and chances are that you have a lot of electrical leaks in your home. It's called phantom power. Appliances throughout your home use power when they're not being used. Stuff like your TV, DVD player, game console, and computer, to name a few, well, they all use energy when not in use. In fact, it's estimated that phantom power can account for 5 to 10% of residential electricity usage. So let's turn back the clock. Phantom power started to get noticed by utility companies back in the late 90s. That's when a growing trend of electronic devices became more and more easily accessible in homes across the country. President George W. Bush signed an executive order that required federal departments to only purchase electronic equipment that would use no more than 1 watt in standby mode. After President Bush signed that order, standby power began to receive more attention. So what can you do to help plug that electrical leak? Well, short of unplugging every appliance in your home, you can use an advanced power strip. These are the next level of power strips, and they do cost a little bit more. This power strip works the same way as the smart power strip, but this time there's no control outlet. Instead, it's replaced with a sensor. You plug in your items like normal, but then you also plug in the sensor, and then you place that next to your TV. Depending on the type of sensor you use, it can detect infrared from remotes and some radio frequencies. So when the sensor reads any of these things, it switches the power on for the controlled outlets. If no remote activity is detected for a period of time, which you can customize and adjust, then it shuts down the energy to all those appliances. But it doesn't stop there. You can find different types of sensors to use elsewhere throughout your house. Sensors that will turn on or off the controlled outlets for you in whatever situation you need. This is a light sensor, sensitive to light. So when a light comes on, so does the power to those outlets. Or there's a sensor that works like a foot pedal. So you can plug in multiple things. Let's take this office for example. You could plug in your lamps, your computer, your printer, and then when you're done working, you don't let it go into sleep mode. You just hit this switch on the floor, and then everything turns off at once. Now you won't be able to get rid of all of the phantom power in your home, but with a little effort, you can make it as small as possible. Here's something you may not know. Switching entirely to LED lights over the next 2 decades could save the U.S. $250 billion in energy costs and reduce electricity consumption for lighting by nearly 50%. Here's something you may not know. If you use a ceiling fan while running your air conditioner, you can raise the temperature setting on your thermostat by about 4 degrees and not see a change in comfort. Just remember to turn it off when you leave the room.
It's always frustrating when you don't get what you paid for, especially if it's an air conditioner. That's why the professionals perform special tests after installing air conditioner units. Meet Randy Novak. Randy's company installs air conditioners, but he also makes sure the air conditioner you just bought is actually living up to the energy efficiency you purchased. Let's go install an air conditioner and learn more. Hi, Randy.
Hi, Pete.
Boy, you guys are already working hard today. Let me give you a hand here.
Thank you.
Now, I know you've got the furnace, the air conditioner. Is it common to have both of those coming out?
It is. They're both the same age and they use components of each other. So most of the time people put a furnace and air conditioner at the same time.
How long is this going to take today?
It's going to take us all day, but I need to get that humidifier inside.
Let me give you a hand.
Okay, thanks a lot. How you doing, Ron?
Hey, Ron, here's that humidifier.
Thank you.
Randy, so we're down in the basement of a home, installation of a heating and air conditioner unit. How long does it usually take in terms of an installation like this?
Typically 1 to 2 days. Most of the time we'll finish an install in 1 day. It can drag into 2 days depending on the complexity of the job.
And I imagine every time it can be a different what you might find, right?
No two houses are the same. Even if they look identical next door to each other, they're a little different in how the setup is.
And getting some of the old equipment out. And I know you had a little adjustment here to get a bigger, maybe an older unit out.
Yeah, that can be a challenge. Sometimes we have to disassemble them. Sometimes we have to take a window out to get some in, and sometimes they'll just go right up the stairway and we can take it out. So that's usually the toughest part is getting the old stuff out of there.
I know you and your company have been doing this for many years. Any strange things that you've had when you've gone out on a call about an installation?
Maybe the strangest thing I can remember is one time when I was doing sales, I had sold a system to a couple, and I went over to the house to see how the installation was going, and the husband asked to talk to me out in the garage, and of course we went out and I said, hey, how are we doing? He said, you're doing fine. But he said, I'd like to ask you to put a dummy thermostat on the wall. We'll put the real one in the closet in the basement. My wife's always messing with the thermostat and she keeps it too darn cold in here, and I want to be able to control the temperature. She'll never know.
That's amazing,
yeah,
Randy.
That was funny.
Now, we talked to the homeowner here and she said it had been about 20 years, but a much more energy efficient system coming in here, and again, saving energy and saving money, right?
Saving energy and saving money. You can typically expect to save about 25 to 30% when you exchange a system that's 20 years old with a system of like we're putting in today.
This air conditioner is a 16 SEER. That's the seasonal energy efficiency ratio. The higher the number, the more efficient the air conditioner, and the less it has to work. That will save you money in the long run. You really look at the house and the whole envelope, right?
Yeah, we do a heat loss, heat gain, and we see how much capacity the house needs. And a lot of times, quite frankly, back in the older days, they oversized equipment, and we just didn't know any better. We didn't have the technology we have to figure out exactly what size each house needs to use for a furnace or air conditioner. So I think we're better at getting the right size now.
The air conditioner is not the only piece of equipment we're installing today. We're also installing a new furnace. That's because the air conditioner has to work with the blower system of the furnace. Changing out both systems at the same time can help make each piece of equipment more efficient. Randy, I know oftentimes your team will get in here and it can be in a small space. I know you can be in attics, and you have to make some real adjustments.
We do. One size doesn't fit all. And a lot of times we think in the Midwest of furnaces just being in basements. They can be in a garage, they can be in a crawl space, they can be in an attic, they can be in a closet, they can be on a first floor. So every house, even in the same neighborhood, could be different as far as where the equipment's located and what we have to do to get the new equipment back in to modify it to work.
And again, you're looking, coming back to that efficiency, what's going to work for that particular home and for that particular homeowner.
Exactly. We want to provide a comfort solution. Efficiency is important, but comfort's important also. And people pay more attention nowadays to noise levels. They pay more attention to humidity levels, and they want to be comfortable as well as save energy.
The most important part of an air conditioner install comes at the very end, and it's not to see if it blows cool air or not. It's about making sure the equipment is performing at the energy rating you thought you were getting. This equipment comes with default factory settings, but the installer's job is to adjust the system for your home. You may need to even ask your installer to do a HVAC test. Not only will it make sure you're getting what you paid for, but most utilities require this test in order for you to get a rebate on the equipment. So we want to know how our system is testing. This is Shannon, he's an HVAC technician. And Shannon, what are the numbers showing you right now?
Well, it looks like I'm a little low on refrigerant. As soon as I add it, we should be right where we need to be.
And that's neat to see for the homeowner, because then they know they're getting exactly what they paid for.
Yeah, I think after this test, it will be running as efficient as it possibly can.
All right, that's great. Well, Shannon, I'll let you finish up here. Thanks for showing this.
Yeah, thank you.
You know, Megan, it really is important to get new air conditioners and furnaces tested. The last thing you want is to pay money for an efficient air conditioner and end up paying more money on monthly bills because it wasn't adjusted to perform at its peak.
What did you think of the wind farm? Those are amazing machines. Just one of those turbines can power over 400 homes. This technology is here to stay.
I got to get up close to a new home built by students. It really is encouraging to see the next generation of builders is finding ways to be more energy efficient from the ground up.
And watch out for phantom energy thieves. DVD players, computers, gaming consoles, they all use energy. And now there are even more advanced power strips that can help you lock out the thieves.
That's an energy cost that can sneak up on you and make it harder for your house to be a powerhouse.
Megan's Wardrobe, provided by Dress Barn.